Hey everybody, there is the date and time, April 11th, 2018, that's Central Daylight Time. There's going to be several videos I'm making for more lunar observations. Some are predictive videos and then actual observations, but first I want to show you something. Some of you may remember my moon here, 6-inch diameter moon globe I got from Sky and Telescope, and my Earth beach ball. Some of you may remember that in the predictive experiment, which I did make observations on. Well, one observation. We had issues while we were up there, mainly with weather, but that video is still coming, I promise. But I'm going to demonstrate something here for you. I am going to show you why the moon appears to swing like this throughout the night, like from this to this, why it does that. So this model will not be to scale, it is to illustrate a point. I'm going to have two cameras. I'm going to have this one, which is going to basically stay right here, and I'm going to have the moon down there when I actually record. I'm going to take this camera, my phone, and I'm going to place it as if you were standing at any latitude, it doesn't matter, and then how you see the moon throughout the night as the Earth rotates. And then that camera will have its own footage, and you should see the swing. So in order for that swing to occur, we have to be on something that is rotating. Now the moon will move through its orbit throughout the night. It will do that, as I've demonstrated in the video before, my predictive video. But I actually thought about moving the Earth, but since I'm not doing that type of experiment, it doesn't matter. I don't need to move the moon. I don't need to move the Earth. All I need to do is rotate the Earth so you can see what happens. Alright, so I guess we can get this started here. I'll do another time hack. I'm going to pause this now. I'll do another time hack, and then when I'm ready to shoot for that there. Okay? Alright, let's do another time hack, just so you can see. Alright? We are going to do the same with this. When I turn this on, the moon is set up. It's not oriented properly, but the South Pole is sticking face at you, and it's a big black spot on the model. Now the reason why I'm doing that is so you can see that motion from this distance. I mean, my kitchen, from my Earth to my moon, 12, 13 feet, I don't know. So it's not to scale. So, okay, where should we put it? We can put it, now remember, Earth rotates from north in a counterclockwise direction, so we're going to go like this. We're going to set this up. If the phone will ever actually switch. We need to be able to see our moon. Oh wait, before I start doing zooms or anything, let's get a time hack on that. There you go. Alright. Now I'm going to zoom in just so you can see the moon clearly. I apologize for the mess, but Sarah has moved in recently. We're still trying to get things organized. Now, if I'm at a certain latitude, in order to see the moon, I have to be, oh wait, we got to start from moonrise. So in order to see the moon, I'm going to have to look towards the east. So, but then, oh wait, I forgot to take into account as if I'm standing on the ground. Alright, so I have to look towards the east. Now what happens as the Earth rotates throughout the night, your vantage changes. Okay? We will see what that looks like. I am going to do that again. I'm going to do another time hack. I'm going to stop it on this, not on here. I'm going to stop it for a second. Do another time hack because the moon kind of almost moved out. The moon kind of almost moved out of view there. Okay. So, let's try that again. See if I can keep this. Zooming in probably isn't the most wondrous idea here. So as the Earth rotates, we have to look, and look how I have to move the kit because I have to change my altitude and azimuth during my observations. And there's moon set. Okay, so I'm going to stop this now. So as you can see, when I'm looking at the moon for moonrise, that direction, I'm looking not only at a certain azimuthal direction, but an altitude, which changes over the course of the night. So in general, the moon appears to get higher before coming back down. But due to the Earth's rotation, what happens is you get that wobble. And you're going to see that with the southern pole, which is a black dot on the moon when I show you that. It's an apparent wobble of the disk as viewed from Earth. They do make telescopes that compensate for that wobble. I tried to get it like that. I just use level mounts when I take photos and stuff like that. But there's something else too. What you just saw would not happen if the Earth was not moving. And I'm going to demonstrate that. Alright, so we are going to do the experiment I just talked about right now. Sorry I stopped the camera. It gave me the red light blinking like it was dying, but it's not. So we're going to do that last part again. Okay, so date and time hack. Hopefully you can see that. We'll do the same thing for here. Now, what I'm going to have to do, as I explained, is I'm going to have to move the Earth this way because the moon will be orbiting that way. I'm not going to move the moon, just going to move my Earth and pretend the moon, or pretend the Earth does not rotate. What will we see? Okay. Well, we would see this. Basically, if you're at any latitude, you're going to notice this also isn't going to make sense very much, because if the Earth wasn't rotating, it would kind of look wonky. But anyway, aside from that. Alright, here we go. Sorry, cat in the way. Gotta zoom in a little bit. Alright, here we go. So what we're going to do is we're going to put us at a latitude, and as if we can only see the moon as it's moving through its orbit, but not the Earth not rotating. Effectively, that is all you would see. Let's try it again, get a little more footage, a little slower. Effectively, that is all you'd see. Our reference point, our black spot at the bottom, would not move. The moon's the position of the moon throughout the night, it would still rise and set, but numerous weird things would happen. But in a nutshell, what would not happen is you would not get that swing. You would not get this. You would get this. This reference would not move. It would point off into some direction, okay? Not relative to the Earth, okay? So, if you want to have any questions, please ask below. Please like and subscribe. I'm really close to that 1,000 mark, but I just can't seem to break it. But anyway, that's it, and I hope you learned something.